Addition of vectors. Okay, now the addition of vectors, or the vectors, they follow two laws of addition. All right, and these are called the triangle law of addition and the parallelogram law of addition. So let us discuss the first one, the triangle law of addition. Now this is the statement: if two vectors acting simultaneously on a plane can be represented in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant is represented in magnitude and direction by the closing side taken in the opposite order. Okay, so basically if two vectors, and you remember how do we represent vectors? We represent vectors with a straight line with an arrowhead. So if you have two vectors that are acting on a plane, and if you can fit these two vectors on the two sides of a triangle, how? Let us have a look. In this diagram, I have these two vectors. I have the vector p bar going in that direction, and the vector q bar going in that direction. And these two vectors, they are acting on the plane of the board. Okay. Now what I do is, in this triangle ABC, I take this vector p bar and I put it here. I can put it there. Why? Because the length of this vector p bar is equal to the side AB, and the direction of this p bar is same as the direction of the side AB. And I can do the same. I can take this vector and I fit it here in the side BC, right? So now if you look at this second diagram, you can see that this vector and this vector are represented by the sides AB and BC. So it means that if two vectors acting on the plane can be represented by the two sides of a triangle AB and BC taken in the same order. Now what does that mean? Taken in the same order means that you go from A to B, B to C without lifting your pen. Okay, without lifting your hand. That is the meaning of same order, right? Then the third closing side. Which is the third closing side? The side AC. Taken in the opposite order will represent the resultant in magnitude and direction. That is what the law means. And what is the meaning of taken in the opposite order? You see here, same order is going from A to B without lifting your hand, from B to C, and again without lifting your hand from C to A. That would be same order. All right, so that is going in the anti-clockwise direction. But then what does the law say? Now the closing side is going in the opposite order. Same order would be from going from C to A. Opposite order would be from A to C. Understand? So this third closing side, that will represent the resultant vector taken in the opposite order. It will represent the resultant vector both in magnitude and direction. All right. Okay. Now here we wanted to find the let's first find the magnitude of the resultant R bar. Okay, so when we say magnitude of the resultant R bar, what are we meaning? We mean the length of this line AC, because the length of this line AC will give the magnitude of this resultant, right? So all we need to do, okay, how do we find the length out here? Let us modify this diagram a little bit, and we will make a bit of construction. Okay, so let us drop perpendicular, and first of all we'll extend this line. Will it extend it that way? Is that okay? Let me use a different color. Let me use light green. Okay, we'll extend it here, and then we will drop perpendicular. Okay, let's use a dotted line for this. Okay, now what will be the direction of this the direction of the resultant is determined by the angle that it makes with the first vector. Okay, so here we have two angles out here. This angle, this is denoted by theta, and another angle here, this is denoted by alpha. Okay, so basically what is this angle theta? The angle theta, if I extend this vector p, it will go along this direction, is it not? So let me call this point here as point N. Okay, so basically this angle theta is the angle between this line and that line, which is the angle between the vector q bar and the vector p bar. Remember that, okay? And alpha here is the angle that the resultant makes with the first vector p bar. Got it? Okay, so now number one, let us find the magnitude of the resultant r. So like I told you, to find the magnitude, all we need to find is the length of the line AC. So we have turned this into a right angled triangle. We can use the Pythagoras theorem. So in triangle ACN, using Pythagoras theorem, you have excuse me, you have AC square is equal to AN square plus CN square, right? Okay, so AC square is equal to, now what is AN? AN is not AB plus BN. So instead of AN here, I can write AB plus BN whole thing square plus CN square. Okay, so AC square is equal to, now I can use the A plus B whole thing square formula. I will get AB square plus BN square plus 2AB BN plus CN square. I believe that is okay. Let me write this as some equation 1. All right, now take another page. Excuse me. In this triangle, which triangle? This one. In this triangle, okay. What will be sine of theta? Sine of theta. We know that sine of theta is perpendicular by hypotenuse. Okay, so which triangle? Once again, BCN. All right, so in triangle BCN, sine theta is perpendicular. Perpendicular here is CN, hypotenuse here is BC, so CN by BC. This is CN by BC. So this implies CN is equal to BC sine theta. Equation 2, and cos theta. Cos theta is what? You know, no? Cos theta is base by hypotenuse. So that will be BN by BC. BN by BC. So here only BN, that will be BC cos theta. Let's call this some equation 3. So in this expression, instead of CN and instead of BN, we will substitute with equation 1 or equation 2. So therefore you have AC square is equal to AB square plus BN square. AB square plus BN square. But what is BN? BN is this. So it will be BC square cos square theta plus 2AB BN. So instead of BN, I will write BC cos theta plus what? Plus CN square. But what is CN? Cn is this. Cn square will be bc square sine square theta. So AC square, this will be what? Can I do one thing? Can I group? Say I have BC square here and BC square here, I can take common, right? So BC square, and then inside of the bracket you have cos square theta plus sine square theta plus 2AB BC cos theta. And you know very well cos square theta plus sine square theta, this is equal to 1. So you have AC square is equal to AB square plus BC square plus 2AB BC cos theta. Let's call this sum equation 4. But what is AC? Look at the diagram. What is AC? AC is not magnitude of R. So AC here is R. What is AB? AB is the magnitude of P. So that will be P. And what is BC? BC is the magnitude of Q. So therefore you have R square is equal to AB will be P square, BC will be Q square plus 2PQ cos theta, which implies only R. This will be P square plus Q square plus 2PQ cos theta under a root. This gives the expression of the magnitude of the resultant, which gives the magnitude of the resultant. Okay. Right, so let us now find the direction of the resultant. All right, so vector quantities always has got magnitude and direction. We have found the magnitude. Let us now find the direction. Now how do we find the direction? Okay, so it is not like east, west, south or something like that. Okay, so here direction of this R is relative to the first vector, always relative to the first vector, and it is denoted by this. It is determined by this angle alpha. All right, so if you know the angle alpha, then you would know the direction of R, right? Because this R is making an angle alpha with the direction of P, and P here is along the x-axis. Got it? So to find the direction of R, all we need to know is the angle. Okay, so let us find the angle alpha, or to make a thing simpler, let us find the tangent of alpha. Okay, so this is number 2. Let me take another page. Number 2, sorry, unhide layer. Number 2, this is direction of resultant. Okay, so here the direction of the resultant is determined by the angle alpha that the resultant makes with which vector? P bar. Okay, so in this diagram, once again, let me have a look which diagram. This diagram once again. So let us take tan tan of alpha. Okay, tan of alpha will be what? Perpendicular by base, so that will be Cn by An. Got it? So therefore tan alpha, that'll be Cn by An. Okay, and what is An? Again, if you look at this diagram, sorry, not that, An is AB plus Bn. AB plus Bn. So I will write here Cn, and this is AB plus Bn. Got it? And what is Cn? Cn, I think we already found before. Is it here? No, not there. Here, Cn is this. Cn is BC sine theta. Okay, BC sine theta. So instead of Cn, let me write BC sine theta. AB plus instead of Bn, it will be BC cos theta. BC cos theta. Cos theta. Okay, so on the left hand side we have tan alpha. Got it? So tan alpha. But what is BC? What is BC? Again, BC is Q, AB is P. So you have BC, that will be Q sine theta by AB, which is P, plus Q cos theta. Okay, so if we know the tan of alpha, then we would be able to know the value of alpha. All right, so this next equation, this gives the direction of the resultant with respect to the vector p bar. Got it? So what is this equation number? Is it 4? Let's call this equation to be unhide this layer. This will be equation 5, and next one, this will be equation what did I do just now? So this will be equation 5. That will be equation 5. And what is this 5 doing out here? This is in the previous layer. That will be equation 6. Got it? So if the question comes in the exam to state the triangle law of addition of vector and find the magnitude and the direction of the resultant, this is what you will do. You will start from the beginning. Okay.